Section 3.1, master level for the tangent ratio. We're going to do a few examples where you're actually going to see how we can apply the tangent ratio. Where could we use it in the real world? So number one, a person stands 2,117 feet away from One World Trade Center. So here's the building, and this distance, which would not be difficult to measure. So we have a person standing here, and that's how far they are away. And we know that the angle of elevation is 40 degrees. So we call this the horizontal. So this angle here, right up to the top, is 40 degrees. From this information alone, we can actually determine how tall the building is. Okay? And this is really useful because if you were to measure the height of the building directly, what are you supposed to do? Stand on top of it and drop a really long tape measure and measure it directly? That is not very practical. But we can use simple trigonometry using things that we can measure much more easily to determine the height of a building. Okay. So we have a right triangle, and by definition, the tangent of 40 degrees, okay, that is equal to the opposite. Well, the opposite is actually the height of the building. So I will label this height as, I don't know, h. H for height. Okay. Divided by the adjacent. Okay. The adjacent is the distance the person is standing away from the building. Okay. Well, all we have to do now is solve for h. So we need to get rid of this 2117. It's being divided. So the only way to undo that effectively is to multiply. But I have to multiply both sides. So this of course cancels because it becomes 1. So 2,117 times the tangent of 40 degrees, that is equal to the height of the building. Okay. Well, these are all numbers that I can work out on my calculator. So I take 2117 times the tangent of 40, and I get, my height is approximately 1,776, and what were my units? They have to match whatever this unit was. This is feet. Okay, and just a fun fact. This number is actually the height of the building, and this was chosen deliberately because the year 1776, that was the year of, well, the year of independence. A person standing on the edge of a 100-meter cliff sees a small boat in the water below. How far away is the boat from the cliff horizontally? So here we have a boat floating in the water. This is a cliff. It is 100 meters. Okay, and we want to know this distance here, horizontally. Okay, so this is a right triangle. All right. We are given that this angle here is 35 degrees. But because the water level is parallel to this line, okay, this must also be 35 degrees. Okay. We call these alternate interior angles. All right. So we can see now that we have a right triangle, and we need to figure out this distance, which I'll call d. And we can use the tangent ratio for that. So the tangent of 35 degrees is equal to the opposite, which is 100, divided by the adjacent, which is d. So that's our equation. All we need to do now is solve for d. So to get d by itself, I'm going to multiply both sides of this equation by d. So now it cancels here, which gives me d times the tan of 35. That's equal to 100. So to get d, I need to divide both sides by the tangent of 35. Again, that's just a number. that I'll work out last. Okay, so that cancels, like so. So D is just that. Okay, so take our calculator, 100 divided by the tangent of 35, and I get D is approximately 143, and this would be meters. The units would have to be the same. Okay, and that number should seem fairly reasonable. If this is 100, this obviously appears to be somewhat bigger, not too much, so 143 seems reasonable. Number 3, in downtown Manhattan, the Rockefeller Center, abbreviated RC, is 3/4 of a mile from the United Nations, UN, and 4 miles from the World Trade Center. From the World Trade Center, what is the angle between the Rockefeller Center and the United Nations by line of sight? Okay, well, the best way to understand this, of course, is to look at the picture. So here's a bird's eye view of the southern part of Manhattan. So here's the triangle. Here's where the World Trade Center is. Straight up here, that's where the Rockefeller Center is. And over here to the right is the United Nations. Okay, and we want to find this angle right here. So you can see I've actually written theta. That's the angle that we want to determine. So I'm going to draw just the triangle that I'm working with. There we go. That's 90 degrees. Okay. So we know that the Rockefeller Center is here, the United Nations is here, and we were told that that is 3/4 of a mile. So that's 0.75 miles. Okay. And what else are we told? And it is 4 miles from the World Trade Center. So that means this is 4 miles. Right? And we are looking for this angle here. Okay? So this 0.75, that is the opposite. This 4 is the adjacent, so we get to use tangent. But we don't have the angle, so we're actually going to have to use the inverse this time. So let's set up the original definition of tangent. So the tangent of theta is 0.75 divided by 4. Okay, these are both in miles. Okay. Now if you were to work this out as a decimal, that's actually no problem. You're not going to get something long and ugly. So this time I'll work it out. Why not? There we go. So if the tangent of my unknown angle is this number here, I need to go backwards and figure out what angle will give me this result. So we use inverse. So that means theta is the inverse tangent of this number, which I'll keep in blue. Okay. So take out our calculator. So inverse tan of 0.1875, I get approximately 10.6 degrees. Okay, that's pretty small, and judging from the picture, the angle does seem, well, not that big. So there's our answer.